Good morning, everybody. Hey, this is our second installment here on SPSS. And before I get started, I just want to provide a general boilerplate disclaimer that this video is not highly produced. It is not scripted. It is not intending to be anything other than a basic down and dirty approach to getting a regression through an SPSS. So if you're looking for some well-produced regression documents and videos, they're out there on YouTube, and by all means jump on it. But this is for my 646 folks, and I thought I would do this for them. So hey, here we are. We're on my lifestyles medicines table. And I've got all that written up, and my regression's done after doing so many over the weekend. I just about was kicked out of the house. But what's the process? Well, let's come here to analyze, okay? And we have all these different opportunities here. Now, there's a couple places you can get a regression. One of them's right here in general linear model. Okay, so we can open this guy up, and we can do some univariate regression. Or we can come right to regression and we can get this party started real simple. And that's what we're going to do, because the drop down box comes in, gives us some great instructions. Now for me, on my particular needs, I wanted to know what was lining up on I exercise at least 60 minutes a day. Okay, take a look at Jack's here. That is not quite in his daily business, all right? Although he did have an extensive weekend. I'll explain to that later maybe. So I have several things I've put in here. You can take these guys and drop them in pretty easily just by poking around here, highlighting. I'm going to pull these guys out. We'll do some different ones. Okay. So it's pretty easy to put these independents in, and these independent variables are pretty important. Now, I have set mine up so that I can do a stepwise regression, which is rather complicated, but I want to be able to see the best fit and best model based on what variables I put in. I recommend you guys do that. I've provided you a Word document that tells you how to write it up, tells you how to transform this result into a report format. So why not? Why not go that far? Okay, so do you have time in your schedule to work out? This is one of my independents. I have access to walking paths. We're going to put that guy in there. Can you afford to go to a gym? We'll put that guy in there. Do you have time to work out? I make time. Let's put these guys in here. All right, so we'll take a look at what this results in. But in general, what you want to do is you want to pile as many of these guys, these independents, into this box as you can. All right, you had 25 questions, so you can run up to, I think this guy will produce and process up to maybe 12 to 15 pretty well on our computers. It may shut down if you put all 25 of them in. All right, speaking of shutting down. Okay, so anyway, back to work. So one of the things that you want to look at here is these statistic parameters that we're setting up here. Now, let's look on this side of the page here if we can. So we got model fit, R-squared change. I didn't go descriptives. You should have already done that. Part and partial correlations, collinearity. Okay, what's all this mean? Model fit, we're going to make sure that we develop and we project and we look at a model fit so we can understand it. We're looking at the relationship or R-squared change as we develop our different models. We're looking at part and partial correlations so that I can see what each variable contributes to my variance, which is real important. I want to make sure we don't have any collinearity problems here. So what that means is if we've got some skewness that's happening, or data coming in that appears to be anything other than random, we're going to find out. We can also find that out through the Durbin-Watson test as we look at our residuals to see if our residuals have any correlative or relationship. So we know when things are being played, okay? Estimates are showing all my regression data will be available so I can look at why things are the way they are. All right, so I got that set up pretty good for us to be informed. Then we want to set up our plots. Now we have some options here. I recommend doing a Z predictor and a Z residual, and the reason is this gives you an idea of whether your data is informing the line it actually establishes in a sort of normative way. The PP plot gives you an idea if there's any problems with skewness or data normative issues. It tells us that there's a problem there. And why it does that is because you have this hard line of your actual prediction line, and then it's doing some background work behind there, seeing where all your independents fall in the z-planes and predictions of those z-planes, and says, hey man, this lines up perfectly with the predictor model. Nope, these guys are way off course, and it's going to show you that. The histogram and normability plot is going to do some of that too. It's going to show us if we've got good data going into our model. Okay, that's the nickel tour of that, which is not exactly I would say as robust as it could be had I scripted this, but that's okay. All right, we're ready to run it. Here we go. Okay, so she cranks out, and we've got ourselves a warning sign, and I know which one it is, and we're gonna back that guy out. So something funky happened here on one, and I'm glad this happened during the video here, because I'll tell you which one it is. This guy, I have access to walking paths. That particular file didn't come out well in Qualtrics, and I don't know why, but it did. Let's put another one in. We'll put something in about sleep. All right, let's do it. We're ready to go. Here we go. Yep, here she comes. All right, cool. So now she's running. Nice. All right. Uh-oh. Uh-oh. Look at this. Just as I suspected. Look at our PP plot. When you see that, that's not so good. Not so good. And you can see over here, we're running a little weird on our normability. All right. So what's it saying here? Well, we did get a good F statistic out of this, which is a good thing. So the F statistic is 20, which is pretty good. So our sums of squares on our means is pretty high relative to our residuals. But what the PP plot's telling us is that only a few of these guys actually work. We can only get one model. And the only coefficient that's going to work that makes sense is I make time to exercise each week. It has a T of actually, in this case, it's going to be 4.496 with significance of 0, so we're good. Good strong T and the major contributor to this. So what's the point? Well, this model didn't work out that well. And here's the excluded variables, and you can see why. We have none of those significant on the T's. And what the T's are telling us is basically, long story short, if they're contributing, are they contributing to this model? And they're not. So that's not cool. Those guys are out. And we only had one that had a significant t-value. And that's why we had this really bad looking plot. So if you get this like this, and you get a plot, a PP plot that looks like that, that's kind of NFG. So get rid of this particular regression and keep trying to get a more normal regression. All right. A normal regression will show all of these guys lined up about this line here. Okay. They won't be blowing all the way over here. They'll be running right up here like a snake, just going wrapping right around this line. All right. All right. So I hope that's helpful to you. There'll be one more installment, and that's how to interpret these. And I'll be back. This is just how to get you here. All right. Take care.